Yes, sir.
Hello there. Can you hear me?
Loud and clear.
All right. So, hello everyone. My name is Michal Bienkowski. I'm software engineer in Averna. I'm sitting in our office in Wrocław in Poland with my colleagues, and I would like to share with you my presentation about test and process model plugins. Can you see my presentation?
Yeah.
Yes.
All right. Okay, so briefly about myself, I'm a software engineer in Averna. Like I mentioned, I have about 5 years experience in production testing and in particular in functional testers, which extensively use an TestStand software, and also because quite popular request from clients is to customize reporting, and sometimes the only way to customize it properly is with use of plugins. I have some knowledge about plugins which I would like to share with you. I'm not sure is that going to be something new for architects, but still I hope you will learn something from it, and if not something new, you will at least refresh what you already know. Okay, so without further ado, let's start with process model, and I'm pretty happy about the previous presentation because it showed us what the process model is, more or less. And there was a really important sentence or really important statement that the process model is built on top of TestStand engine. And that's important fact to also understand that plugins are actually built on top of process models. So plugins aren't part of TestStand engine, but they are introduced in process model, so they are a big part of actual process model architecture. And without understanding process model, it's sometimes confusing or more difficult to build properly working plugins or utilize all the possibilities or functionalities provided by this solution. So let's start with short example with process model. What is it once again, and how it changed also. So let's say we have some product and we need some production test of this product. The same product can have production test, but also might be field return test. Whatever it is, we know that those tests are product specific and they can differ between products. So we have some set of tests for a product. Then we can say that we might have multiple set of tests because our product is just part of bigger family of products that we want to test. Then we know that there's no point of testing if we don't have proper reporting. And proper reporting required proper traceability of the product. So we need some kind of serial number tracing of the product. Then, of course, we might want to scale it up so we can add some sockets and do parallel execution, as was mentioned before. And then, of course, we would like to loop all the things to test the whole batch of products we have. And then we can add a lot more of things to the process that we have. So what I meant here is that we have separation between the product-specific aspects of the test system and also aspects related with the whole process. And those gray squares you can see are related with the process and process model. we have can be used to define such functionality like built-in self-test, integration with factory information system, custom cleanup or calibration, whatever we like and whatever our customer required for every product can be defined in this process model. Yeah, so that's what we have. And one thing to notice here in this diagram is that reporting is depicted as a big part of a process model, but it is kind of tightly coupled with this process model. And what I wanted to say here is that the architecture changed between TestStand 2010 and 2012. So before TestStand 2012, we had this monolithic architecture, which has this result processing reporting inside of process model. It was tightly coupled processing, and therefore whatever we wanted to customize reporting, and that's the thing that, like I said, is quite popular in projects, then we would need to influence the process model itself. But since 2012, National Instruments introduced this new architecture based on plugins, and they added model support sequence, which enables us to run numerous plugin entry points inside of our result processing sequence file. And therefore, now we have possibility to configure many instances of result reporting plugins, and also enables us to run them in parallel. And also, it gives us the possibility to create our own plugins and do whatever we like with them. And yeah, so we can say that now it's kind of like in object-oriented programming. So we have something like a class, which would be the plugin sequence for plugin result processing sequence, and instances of this reporting plugins as like object. But this this naming maybe not be the best, but that's a subject for another discussion. But we can see that there is some similarity, and that's why even I use this terms of instantiation of plugin. So let's go back to this simple example. So we can replace the tightly coupled reporting with something more independent, and we can see that we can use many formats of reporting now, and we can customize it wherever we like. What is also introduced is change in the threading of result reporting. So before the architecture change, the only possible execution was to run tests and result processing in one thread. So after each test, we would need to test for a result to be generated, and therefore we lose time for something which can be done in parallel. So now we have this possibility to configure result processing in a second thread. So now it looks more like this. So we can run each test in each product sequentially without waiting for the report to be generated, because they are basically generated in separate threads. So this is more or less also parallel execution of result process. Okay, let's now have a closer look at the sequential process model callbacks. What I mean that we need to understand more or less how the process model works, to know where in which moment process model entry point is called, and more or less how it works. So first of all, we have two execution entry points, which can be found in this execute menu. Those are the sequences which are basically defines our process. Those are the place where everything starts. When we run one of them, the process is just starting. So the test UTs is in sequential process model is running our product test in sequence one by one. And it has this internal loop, which enables us to run the whole batch sequentially until all the products are tested. And single pass is running only one iteration of this loop. So they're basically almost the same. So I will further focus on test UTs. Then we have set of callbacks, which can be used in client sequence to customize or alter basic process model behavior. And I will talk about the first three columns in a moment. And I will not talk about the last column because I believe those callbacks are more specific to the particular process result processors. And I want to talk more in general about plugins, not about specific functionality of this plugins mechanism in process model. So let's forget about them at the moment. There's also one engine callback, which is used in on-the-fly result processing. And I don't want to talk about that either because it's, in my opinion, at least quite advanced topic, which deserves separate presentation maybe. So let's forget about that at the moment. And then we have these two configuration entry points, which can be accessed to configure menu, and they are used to, first of all, configure options of the process model, which was shown in the previous presentation. And also we have configure result processing, which calls, which opens this result processing window, in which we can configure our plugins. So to see this extended view of result processing window, we need to click Show More Options. And then you can create your own custom result processing configuration. You can just enter, add some more plugin instances to this list, enable them or configure, or enable or disable, configure the options, and also configure the threading, which was mentioned before. So we can configure them to, by default, they are configured to run in new thread, but we can disable this, or we can set that we want them to run in new thread, but they need to be complete before next UT. Okay, so we can alter this list with those two on the right. Then we have a list of all the configurations that we have defined. So we don't need to change the list each time we want to mess with our custom plugins, for instance, when we develop them. We can just create another configuration here and just use the list here. And also there's advanced button. I will talk about later that because that's the place where we want to go when we want to create new plugin. And there are also configuration for on-the-fly reporting, but I don't want to talk about this. Okay, what's also important here is that we have 7 plugins configured here, but we used only 4 sequences here. So I think that's important to notice that even that we are calling 4 plugins, they have more configuration. So that's the thing I was mentioning before, that we have something like a class, which would be in this case, for instance, NI report generator sequence file. And we have 3 objects of this class, and they are configured here to use HTML, ASCII, and XML configuration. Yeah, for this reporting tool, and But also that's important to notice that when we actually call it, we call each time the same sequence file, but the only change we do is we are providing different parameters to run this sequence. So that's how it's actually implemented in the code. Okay, so let's now walk through this process model, and let's find out where this plugin entry points are located. So we start in sequential process model with initialization of the whole entry point. So the name is basically quite descriptive, but to go in more detail, we basically configure test sockets, station info. We add some more results to this. We check the client file, and also we provide the opportunity to alter model options with this callback in client sequence file. And also, also the options are in this file, in a file shown in the slide. There we have also the place where we load the configuration for the plugins. And this is basically merge configuration from result processing and add-ons. So if you don't know that, because it's not that popular, add-ons are basically plugins, but they don't need to be enabled to be added to the configuration. So the only thing you need to do is just place the result processing plugin inside of proper directory, and it will be automatically loaded and merged inside of this configuration. Next, we have model plugin begin subsequence, which is quite interesting and even quite confusing maybe. So the purpose of this sequence is to initialize model plugins. So the list of plugins we have in the result processing window are loaded inside of this sequence, but we can alter the list through the model plugin configuration callback inside of client sequence. So it might normally mess up with the indexes. So to have this in order, at the beginning we have a loop which creates shallow copy of all result processors configured in a result processing window. And with this shallow copy, we can then initially run initialization of each plugin. And then we can run model plugin configuration. We can reorder the plugins. We can enable them or disable. And then we need to, once again, go through the initialization of individual plugins, because the list of plugins can be altered in this plugin. So one more time. First, we have creating shallow copy of the processors. Then we have creating plugin cache, which is basically loading processor files inside of engine cache. Then we have initialize plugin entry point. The yellow one, I depicted all the yellow icons are basically here plugin entry points, which are the sequences inside of our plugin. I will go to that in a couple of slides. So we have initialization, which is just initialization of some variables that we need to use inside of plugin, but there is a note that we should not use it to, for instance, create some resources or do something more important, because we can alter everything after this entry point inside of a callback, which is called after that. So we have initialize and model plugin options callback. Then again, model plugin configuration, and also again initialization of every changed plugin inside of plugins list. At the end, we have again iteration through all the run orders list of plugins, and we call every configured begin plugin entry point to initialize some resources. We can open a connection to some resource and stuff like that. And then the complementary step for it would be end, which is called in the process model callback. So we have begin to acquire some resource and end to release the resource. That's the place inside of a plugin which should be used to such thing. Okay, next we have the process setup callback. That's more about main process model. Not that important in terms of this presentation. Then we have pre-UT loop, so just a callback before we enter the loop for each product test. And then inside of that loop, we still have another callback, pre-UT, which is used to display this UT information window, inside of which we collect the information about the product we test in this loop. And then we have complementary pre-UT plugin entry point side of our plugin, which can be used wherever you like. It's not also that important. And then we have UT start, and that's more important. So that's basically a place where we might prepare resources for the particular unit, for the particular product. For instance, we can create in here a report object for our product. Then we have pre-main sequence, so setup for main sequence. Then we call main sequence. So that's a client sequence with our custom test. Then post-main sequence, and what's the most important part in the plugins is UT done plugin entry point, which is also quite complex, but if you look closer at that, it's not that scary. So we start with looping inside of run orders sequences. So we are taking UT done entry points for every plugin configured. And then we can have two options. We can run it in new thread or not. So that's a thing I was also mentioned before. If we don't have new thread, that's pretty simple. We just basically call this UT done plugin entry point in the same thread. And then we have, inside of that, we have result processing. I will talk about that in a minute. But inside of this UT done, basically traverse result list and create a report object. And then you can save it or do whatever you like. But about that in a moment. So what happens if we have configured it to run in a new thread? Then first of all, we create a notifier, which will be used to synchronize this new thread with the process model. So plugin will be called in new thread, and we require some synchronization method to do it, and this notifier is used to that. Then we have a call for the UT done entry point, and that can be done also with additional options. So if we have enabled to complete before next UT, then this option needs to be also configured in new thread configuration. And every of them is also configured to initially suspend the execution. So that's a thing that's I think a trick, but it's nice to have it to initially suspend new thread. Then you call the thread, and after you know that it's up and running, you can resume the thread from the main process. And after that, you basically wait for the notifier to from the plugin to notify that it's okay to proceed with next step. But you're waiting for a notifier, but also there is a timeout in that, which goes to a wait step, which basically verifies if the thread is still up and running, because it might be not running because of some kind of error or something like that. So you have a special mechanism here to ensure that you have the notification if thread is running, but you will not wait indefinitely if the thread is not running. All right, next. Next, what we have is post-UT. And again, in sequential process model, it's not special in any way. It's just actions that you can do after you process the results. And then you have post-UT, which displays the status. And that's the whole main loop. After which we have post-UT loop. Is more, again, something which you can use inside your process model. Depends on the application. Process cleanup, that's a cleanup of the whole process. And after that, we run entry points, plugin entry points for every plugin which called begin plugin entry point. So that's a place I mentioned used for releasing resources and things like that. Right, now let's have a look how to create the plugin. So, where to start? First of all, I recommend to open examples. By the way, you can easily access examples through Workspace, through Help. Then you have the whole list of available plugins in a tree view. And there are two nice examples inside of customizing result processing. They are about model plugins. And I first of all recommend to look at them. And they are doing what they should do, and they are a good starting point when you want to start developing that. I don't recommend starting from scratch using any documentation like they have an article in which they specify what you need to do to start the plugin. I think that's not the best option to start. I would say that start with those examples, then you can go to default result processors inside of TestStand components model plugins directory. There is the default result processor that TestStand used. I think that's a more advanced topic. It's a very good plugin to understand more advanced topics. But so after you start with examples, you can look at those inside of TestStand directory. And after you feel confident enough to start working with your own, you think you understand more or less how it works, maybe perhaps, or thanks to this presentation also, then go to configure, result processing, show more options, and then advanced. You will see this this window, and there is the button you should click. After that, you will generate basic plugin. So that's a starting point for you. You will see that kind of message, and it's basically saying that the plugin is ready to use. It is configured as a result processing plugin. The required data types are prepared for you, and you just need to figure out which plugin entry point you need to use and what kind of data you would like to share between those steps. And about the data, first of all, you should look at default model plugin component description in file globals. There is this plugin specific container. This is the place where you should customize your data. That's the place where you can put your custom options or custom runtime variables that you will use during execution of this plugin. So briefly about them, options, those are the data used to use in pair with basic process model options. And additional options, it's, as it says, additional options container. And by default, in result processing window, you don't see this button for additional options configuration. And usually, you don't need to use it. So I assume you will just use options. And then there's the runtime variables. Those this is the container inside of which you usually will insert your report path or report object. And you can do it like if you use parallel process model, then usually you can also separate runtime variables. You can do the grouping of runtime variables for the controller or the per socket, as you can see here. What's else? So the default container you can see here is used to initialize the plugin. So when the plugin is created inside of result processing window, it is using this container to pound the plugin, let's say, to create the instance of it. And there is also a category-specific container. This is used to specify settings for result processing category plugin. And at the moment, there is only one category, which is result processing category. And there is also base container, which has a lot of different settings for the plugins, like information can it be used with offline result processing utility, or it can be used with on the fly, should be new thread, or basically is it enabled or not. So that's a thing that you should focus on. And also there is always initialize flag, which is important if you want your plugin to be initialized whatever you have configured inside of result processing. Thanks to this flag, you can basically enable this plugin programmatically inside of one of plugin entry points. So that's a thing. That's the reason why you require this complex initialization with 3 loops inside of begin sequence. Then we have also runtime variables, mostly specifying things for synchronization, but there are some other things not that important. And okay, let's have a look at plugin entry points that we have by default inside of our plugin. So when we create this default plugin, this starting point for our plugin journey, we can find it in public TestStand folder. We can put it inside of add-ons if you like, but it doesn't matter at the moment. So the thing is that we have those plugin entry points that we can configure or implement inside of them our functionality for our plugin. And these entry points are the sequences called inside of our plugin process model in the places I highlighted with yellow icon of sequence. So those are this entry points, and the only 2 sequences not mentioned before are for configuration plugin options. So those are the callbacks used to, or entry points actually used with plugin specific options and additional options data type. Okay, let's start with some example. Let's say we want to create a plugin which converts the result list in the way that it takes all the names of every step that we have configured to record it result. So we take all the names as well as the status. We want to save it as a text file, simple text file, just like that. So to do it, we need to use only those 2 plugin entry points, which is UT start and UT done. And to be honest, we could just use only UT-done, but let's say that we want to do it this way. Before I explain how to do it, let's have a quick digression about how report class looks in TestStand. So, in my opinion, in TestStand we have many places where we can feel confused, and that's one of such places. And the reason behind is that we can access some objects from many places, and we access the same object from many places because there's like cross-referencing the same thing from many places. So report object is one of them. So we have an execution, which is a main thread of our process, and the execution has always at least one report object, which can be accessed through execution.report. But there is also execution.reports, which is collection of every report of this execution. So if it has all the reports, then it has the main report as well. So that's one of the places. So we can access this main report from at least two places now. And what's more, report collection has also this field called active report, which is specifying which report will be displayed at the end of the execution inside the report view window. And this is pointing to main execution report. And therefore, it also mains to the same object inside of this collection. So as you can see, we can access the same thing from so many places. And in the examples I mentioned, you will see how this is used to create a report object inside of test UT start. Another thing, which is also confusing, is the way how we can work with report objects. So we can work with them through method called append, which I think is more old school, but I'm not sure is that true. And it's using strings, basically. It's string-based method to create a content of the report. It is still used in the process model to create a message if we don't have report data to display at the end of the test. So this method is used then. But I think the better solution to use are report sections. That's another class, and that's an object that can create tree-like structure of data, which I will show you right now. So we can create report section object through new report section method. It's basically return report section, which is not at the moment part of this report, but it just basically returns the report section. And this report section, as well, every other object of this class contains three fields for text, for the content basically that we can add. So header, body, and footer. Usually you will use body to enter the text. And then each of this report section can have also report subsection, which is collection of another report section. So we can, as you can see, you can create a tree-like structure of data inside of this report, and this is, I believe, more easily to work with when you want to create more complex report structure. And after you create the structure, you can easily add it to your report section. And after you do it, you can just return all the text you have grouped in this way. Okay, so if we know that, we can look how to use this knowledge to create a report. So in the UT start, first of all, we want to create a report instance. So that's a plugin specific runtime variable report instance object. To do it, we need to juggle with this active report object, and that's by default how it's done in the TestStand. So we were trying to find active report and replace it with with our new instance. So reports replace is creating new report instance if we do not specify anything. So we can, by calling reports replace, we can either create a new report instance or replace the active report inside of reports collection with our new report instance. So that's kind of tricky, but that's how it works. And then we just simply create some kind of report file name and directory. So we basically create a path for our report. And after that, we run our main sequence, we run our tests, we collect results, and we can run the UT done after that. And what we have here, first of all, is we collect all the volatile information before we unblock the calling thread. So we have the moment here at the beginning is used to collect every information that can be that's volatile. So like for instance, report instance or result list from the main sequence. And after we collect those information in this inside of our locals variables in this entry point, we can call the notifier to unblock the calling thread. The notifier, the only notifier I mentioned in this presentation, so I hope you remember that. And after that, we create a new report section, which will be used to collect results from a result list of our main sequence. So the next thing is we need to execute some code, which I will show in a moment, to recursively access every result from the result list. And after that, we use report section to save it in a file that we specified in runtime variables. And therefore, we have our report. And the code, the recursive code I mentioned, looks like that. And what is doing is that it takes every result list item and look for each of them. So you need to look through all the result list. Then you access the properties that you are interested in. So in my case, would be name, step name, and status. Then you just need to concatenate this string in some way, and you insert it into the report section you created before calling this VI. And at the end, you repeat the whole thing recursively for every sequence call and post action that you have inside of your result list to access every nested sequences that you have. And that's basically all. That's all you need to create a plugin. Some simple solutions. So that's a thing. That's a starting point. That's all the information that you need to have to say that I know how to create a plugin. And at the end, I have also one curio, let's say. I don't know how it's called. So funny thing from the examples. So inside of any simple text report, LabVIEW sequence, you can have, you can find inside of UT done sequence this kind of recursive solution for finding result list. And it's saying that LabVIEW does not support recursion directly, and there is a dead link which explains that. And to overcome this situation, let's say, you need to do it as you can see in this diagram. So you call the result processor list asynchronously to simulate this recursion inside of that. So that's not true what they are saying in this example. So we can use recursion. I use that in my example. So every call I use was recursive, and don't use this as a common practice or something like that. So don't think that's true. Okay, so I can say good luck with your plugins. I hope now you will know more or less how to start doing it. It's not something scary. It's pretty easy to do it if you know how to do it. And also, I would like to thank you for giving me this opportunity to show you this presentation. And have a good rest of this meeting and also rest of the day. If you have any question, of course, I'm still here and I might try to answer it.
So can you see Ollie's comment?
I'll just read it out.
Moment. Yeah, so the question was, what's the advantages of using model plugins compared to just overriding process model callback? I would say that we have many steps of process model customizations, and that depends on the application. If we want to simply add just, I don't know, address of the facility where the report was generated, we can do it much simpler with the built-in report processors. But if we want to create a report which is completely different from what we have in built-in sequences, built-in processors, then perhaps it's just easier to create your own plugin. So in my case, I had just I needed to create a plugin which produced a text file report suitable for the client customer database. So I just needed to because that's that's what they define. They needed to have this weird format of this text file. So I just said to myself that okay, I will just create my own plugin, text-based plugin, because it's easy to do, and that's all. I don't need to configure heavyweight plugins. I just create my own lightweight plugin for text processing. That's how I do it. And inside in the National Instruments material, you can find a good article about result processing customization, inside of which you can find a diagram which guides you which direction you should go to customize in particular case. So I'm not saying that creating plugins is better than callbacks. It's just different case. You use it in different case. Is that the answer? Am I answered? Can you still hear me?
Yes, we can.
We can, yes. Yeah. Yeah. So, do you want to chip in?
Yeah, so the other thing is obviously there is process model plugins are really, really powerful, and it's not actually just necessary to use them for result processing. That's the only thing that NI decided to do with them. So what we, for example, here do at Abaco is we are in the result plugin, we are actually evaluating the barcodes or the serial numbers that we put in, and are from there analyzing what product we're actually dealing with, and are determining what test actually needs to be run. Subsequently, still in the plugin, we are now downloading the actual test sequences from Perforce, from our source control system, and are then overriding the execution of the main sequence to use the actual real sequence that we want to run. So we actually don't start our tests with the test sequence that we are eventually going to run. We are starting our test with a dummy sequence, which is completely empty. And just the plugin is then going to determine basically what is going to happen with that. So it has nothing to do with results processing in our case, but it is just something that you couldn't just do with process model callbacks, because your initial sequence is just empty, and at some point you're just abandoning it and are not actually actually going to use it any further. Which means the only other option that we would have had is to modify the process model. And as I already mentioned, that is messy. We did cave in the end, but I think the modifications that we have made are minor and have nothing actually to do with this.
All right.
Okay. All right. But thank you so much. Yeah, there's a lot to take in. Any more questions? All right.
It's really easy.
Yeah. Yeah. Thank you so much.